Hello students, in this class we are going to discuss some of the most important objective questions from the point of view of CBSE exam. Okay, so let's see the question number 1. A small electric lamp is placed at the focus of a convex lens. When the lamp is switched on, the lens will produce, the options are converging beam of light, parallel beam of light, diverging beam of light, and is diffused beam of light. So as we know that we are dealing with the question number 1. As we know that if we have a convex lens and if an object is placed at its focus and an object is placed at the focus, then from the object, when ray will strike the lens, then after passing through the lens, the ray will become parallel to the principal axis. Okay, this is the concept that we all know. Now at the focus, according to the question, at the focus what we have placed an electric lamp. It is given in the question, there is an electric lamp. So if at the focus there will be an electric lamp here, suppose here is an electric lamp, it is a lamp, electric lamp, then what will happen? The ray after a refraction from the lens will become parallel to the principal axis. So we will get parallel beam of light after refraction, yes or no? So the correct option will be option D, option B, that is we will get parallel beam of light. Now let's see the question number 2. In question number 2 we can see that first read the question. A real and inverted image of same size is formed by a convex lens when the object is placed at, your options are, at f, at 2f, between f and 2f, between f and optical center. This is a concept from the image formation, and we know that if here is 2f1, 2f1, f1, here f2, and here 2f2. And we know that if an object is placed at 2f1, then we get an image of same size as that of object and placed at 2f2. This is a concept that we know. And what kind of image we get here? We get what kind of image we get? We get a real image. We get real image here, and real image is always inverted. Real image is always inverted. So here it is the object AB, and its image here is A dash B dash. So what will be the answer? The answer will be the object will be at 2f1. That is, from the options, the answer will be B. That is at 2f. Now let's see the question number 3. A convex lens is a diverging lens. So first option is wrong. A convex lens is a converging lens because it converges. So this option is wrong. A convex lens, option B, is thicker at the middle than at edges. Yes, this is correct, because as we know that about a convex lens, that a convex lens at the center it is thick, here we can see that, and at the edges it is thin. At the edges it is thin. So the correct option will be a convex lens is thicker at the middle than at the edges. So option B is correct. Now read the question number 4. A ray of light traveling in air falls obliquely on the surface of a calm pond. It will, okay, so about the question number 4, first let's draw a diagram. Let us suppose it is air and below here is water. And we know that between air and water, refractive index of water is more, so water is a denser medium and air is a rarer medium. and the light is going from air into the water. Light is going from air into the water. And we know that when light goes from when light goes from a when light goes from a rarer medium to a denser medium, then it bends towards the normal. So now go with the options. Go into the option number A. Go into the water without deviating from its path. So this option is wrong because there is bending takes place. Deviate away from the normal. It is also wrong. Deviate away from the normal when light goes from denser to rarer medium, then it deviate away from the normal. Now read the question number C. Deviate towards the normal. Yes, this answer is correct. Because when light goes from a rarer medium to a denser medium, then it bend towards the normal. Here we can see in the diagram also. Now go with the question number 5. Question number 5. A thin lens and a spherical mirror have a focal length of 15 centimeter plus 15 centimeter. Okay, so among the mirror, we know that there are two kind of mirror. One is concave mirror and the other is convex mirror. Concave mirror and convex mirror. And we know that for concave mirror focal length is negative and for convex mirror focal length is positive. Now come for lenses, and we also know that we have two kind of lenses. One we have convex lens and other we have concave lens. And for convex lens we know that the focal length is positive, and for concave lens we know that focal length is negative. Focal length of a concave lens is negative. This thing we know. So my dear, in the question we have given plus 15 centimeter. Plus 15 centimeter means that the focal length is positive. Focal length is positive means yes, the focal length is positive means we can have a focal length positive is for convex mirror and focal length is positive for convex lens. Okay, so both our answer will be what? Both will be convex, convex mirror. Or so for convex mirror and convex lens focal length is positive. So option A is correct here. Okay, so now we are going to see the question number 6. Okay, let's see the question number 6 now. Question number 6 here is the power of a lens of focal length 25 centimeter in diopter is. Okay, so my dear, question number 6, what is the focal length given? Focal length given 25 centimeter, and we know that whenever we have to find the power of a lens, we have to put focal length in meter. So 25 centimeter is equal to 25 by 100 meter or 0.25 meter. Now we want the power. So power equal to, my dear, power equal to 1 by focal length. So put the value of focal length here. So 0.25 meter. So in this formula we put focal length in meter, and what focal length we got in meter? 0.25 meter. Okay, let's simplify this. So this is equal to 100 by 25 meter inverse. 100 by 25 meter inverse. What is 100 by 25? It is 4 meter inverse. This is our answer, and we also know that meter inverse is equal to diopter. So the correct option is option C. Option C is our correct answer. Now we are going to see the question number 7. Read the question first. A lens is a power of, what is the power given, my dear? Power given is 0.5 diopter. This is the power we have given. Now we have 4 options. And among the options we can see that there are given some concave lens and some convex lens. And we know that if power is positive, it means that the lens must be convex lens. The lens must be convex. So the option from the options we can remove the options which are with concave lens. So option A we can remove, and option D, it is also concave, so we can remove. So our answer will be either option B or option C. Okay, so now we are going to simplify this. Let's see. Power equal to, my dear, power equal to 1 by F. Yes or no? So power equal to 1 by F. So what is F from here? F from here is 1 by P. Now put the value of power from the question. What is the power? 0.5 diopter. Diopter means meter inverse. Meter inverse will go up, then it will become meter. 1 meter by 0.5. Now 1 meter is equal to 100 centimeter. 100 centimeter by 0.5. First, let's see the options are given in meter or centimeter. Options are given in meter. So there is no need to convert 1 meter into centimeter. Just simplify this. So here it is equal to 1 meter by 0.5. 0.5 means it is 10 by 5 meter. 10 by 5 meter is 2 meter. So 2 meter will be the correct answer. Let's go with the options. 2 meter. There are I'm not getting any options from 2 meter. Wait a minute. I think I have done somewhere any mistake. 2 meter. 2 diopter. Oh, sorry. No, sorry. Yes. Our option is, no, we are going to the question number 7. So the correct option is 2 meter. No, yes, 2 meter. So 2 meter, the answer will be C. Option C will be correct. A convex lens of focal length 2 meter. I was actually reading the options of question number 8. Now go with the question number 8, and we are going to do the question number 8. The power of lens is, what is the power given, my dear? Power of the lens is given as minus 2 diopter. They are asking the focal length. They are asking 2 diopter means 2 meter inverse. They are asking the focal length. We know that power equal to 1 by focal length. Yes or no? In the question they are asking focal length. So what is focal length from here? Focal length from here is 1 by power. What is power? Power is minus 2 meter inverse. Let's see the options first. Our answers are given in meter. So no need to convert in centimeter. So meter inverse will go up. So it will become 1 meter by minus 2. This is equal to minus 0.5 meter. So minus 0.5 meter. So the correct option is option number C. So C is the correct option for the question number 8. Now we are going to see the question number 9. Okay, listen very carefully. It is a very good question. If the magnification of a lens has positive value, the image is, the options are real, option B virtual and erect, option C inverted, option D none of these. Okay, so now we are going to see the question number 9. Magnification is positive. So my dear, question number 9, magnification is positive. What is magnification? Magnification equal to size of image by size of object. Magnification positive is, it means that the sign of both h dash and h will be greater than 0, because h is always positive, and m is also positive. So from the so m is positive means what? M is positive means both h dash and h will be greater than 0. And when h dash is greater than 0, when h dash is greater than 0, my dear, that is when the size of image is greater than 0. Size of image is greater than 0 when the image is formed above the principal axis. When image is formed above the principal axis, that time only our h dash is positive. And when image is formed above the principal axis, then that image will be always which image? It will be erect. Here we can see that the image is erect image, and we know that erect image is always virtual. Okay, so option number 9, image will be erect and virtual. So question number 9, the correct option will be option number B. So B is the correct answer. Now let's see the question number 10. If the magnification of a lens has a negative value, the image is. Okay, so question number 10, here we can see that question number 10. Go with the question number 10 here. If the magnification of a lens has negative value, okay, in the question number 10, what is the magnification? Magnification is negative magnification. Magnification is negative. So my dear, when magnification is negative only when see here, h is positive and magnification is negative, it means that h dash will be negative, then only m will come out negative. Now negative divided by positives will give some negative quantity. So h dash is negative. When h dash is negative when the image is formed below the principal axis. Yes or no? Whenever image is formed below the principal axis, then our m is negative. So my dear, h dash is negative, and when image is formed below the principal axis, here we can see that the image will be what? Inverted. The image will be inverted. उल्टा इमेज बनेगा, और जब भी उल्टा इमेज बनेगा then it means that image will be what? That will be real, because real image is always inverted. Yes or no? So the options for the question number 10, real and inverted. So option A is correct. Option A is correct for the question number 10. So now we are going to see question number 11. Question number 11. Okay, question number 11 is a very beautiful question, and many students get doubt in the question number 11. Let's read the question number 11 first. Beam of light are incident through the holes A and B and emerges out of the box through the holes C and D respectively, as shown in the figure. So options are, which of the following could be inside the box? बॉक्स के अंदर ऐसा कौन सा आपका ऑप्टिकल डिवाइस रखा हुआ है? ठीक है, योर ऑप्शंस आर a rectangular glass slab, option B a convex lens, option C a concave lens, and option D a prism. See here, see my dear, inside the box, it is possible only when that inside the box there will be, I'm talking about the question number 11 here. It is possible only when that inside the box there will be a rectangular glass slab, and the rectangular glass slab must be inclined in this way. Why? Let's see. Let us suppose a ray of light strikes the rectangular glass slab here, and we know that whenever light goes from a denser to rarer medium, it bends towards the normal. Okay, now the light is going from denser medium to rarer medium. Okay, and whenever light goes from denser to rarer medium, it bends away from the normal. So now it will bend away from the normal. Okay, so this is the situation. Here we can see that. Okay, so what I want to say that which options will be correct? Option number A is correct. There will be a rectangular glass slab inside the box. Okay, which box? The box inside the yellow. Right, our yellow color is the box. So there must be a rectangular glass slab inclined in this way, which I have drawn in the diagram. And if it is placed, if it is inclined in this way, that is our rectangular glass slab, then only we will get this kind of this kind of rays which is given in the diagram. So for question number 11, option A is correct. Option A is correct. Now go with the question number 12. Question number 12 is a very good, beautiful question, my dear. So let's see the question number 12. A beam of light is incident through the holes of side A and emerges out of the holes on the other face of the box as shown in the figure. Okay, good. Which of the following could be inside the box? Okay, which could be inside the box? So my dear, as we know that if we have a convex lens, and whenever ray of light falls parallel to principal axis, then what happens? They converge at the focus. The ray passes through the focus. Yes or no? We all know this thing. So these are the conditions. Okay. So my dear, now incident emergent out the other face. Which of the following could be inside the box? So here we can see that there will be only a convex lens, and this convex lens is present inside the box. Okay, this is the box hour, and the convex lens is present inside the box. So we will get the rays in the similar way that is given in the diagram. Okay, so I think this question is clear. So the correct options, the correct option for question number 12 will be a convex lens. That is option B is correct. Now go through the question number 13. Question number 13. A convex lens of focal length of 12 centimeter. Okay. At which of the following positions should an object be placed so that this convex lens may act as a magnifying glass? So my dear, first I am going to give you a very little information about magnifying glass. We all have seen magnifying glass, yes or no? What it does guys? Magnifying glass, suppose it is a magnifying glass. Okay, what it does, we see an object. Suppose here from this side I'm seeing an object. Suppose object is here. Then what this magnifying glass does, it gives a magnified image. Of the object. Suppose this is the object, this is the image. So what a magnifying glass does, it magnify the size of an image, and we see the image. So my dear, let's talk about the question. Yes. At which of the following positions should an object be placed so that this convex lens may act as a magnifying glass? So my dear, here we can see that for a magnifying glass, object and image are at the same side. And if we will talk about lens, convex lens, then for a convex lens, when the image and object are on the same side, tell me, when image and object are on the same side, when object is placed inside the focus, we know that image and object of image formed by the convex lens is on the same side as that of the object. Yes or no? This is our image, this is object. So whenever object is placed inside the focus of a convex lens, what kind of image we get? We get a virtual image. Yes or no? I can draw the diagram also. We can draw the diagram also. Suppose this is one ray. It will pass through the focus this side, and one through the optical center. So again it will be converged somewhere here. So yes, what is the focal length given in the question? Focal length is given. What is the focal length given? Focal length is given 12 centimeter. It is 12 centimeter. So where is the object, guys? What is u? This is u, object distance. So u, here from the diagram you can see that u is less than 12 centimeter. Yes or no? U is less than 12 centimeter. And from the options we can see that there is only one options whose value is less than 12 centimeter. Yes or no? That is 9 centimeter. All other options are greater than 12 centimeter. So the correct answer is option number A. Now go with the question number 14. Let's talk about the question number 14. This is also very good question. A figure shows a ray of light as it travels from medium A to medium B. The refractive index of medium B relative to medium A is. Okay. So in this question, what we have to find? In question number 14, what we have to find? In question number 14, we have to find refractive index of medium B. Refractive index of medium B relative to medium A. Relative to medium A. NBA. What is NBA? NB by NA. NB by NA. That is refractive index of medium B by refractive index of medium A. We know that. What is N2A? Refractive index of medium 2 with respect to 1 is what? N2 by N1. In the similar way, NBA, that is refractive index of medium B with respect to A, is equal to refractive index of medium B divided by the refractive index of medium A. Okay. So, my dear, what we will do, from the diagram we can see that we can apply the formula. We can apply the formula. What it is called? We can apply the formula. Snell's law. What Snell's law says that N1 sin I equal to N2 sin R. This is the Snell's law that we all know. And here we can see that in medium A, our incident ray is present. So 60 degrees is our angle of incidence, and this 40 degree, that is this 40 degree is our angle of refraction. Medium A is our medium 1 and medium B is our medium 2. Now put these values in the Snell's law. What is N1? N1 is refractive index of medium A. What is sin I? Sin I is 60 degree. I is 60 degree. What is N2? Refractive index of medium B. What is angle R? Angle R is 45 degree. And what we have to find? We have to find NB by NA. What is NB by NA, my dear? From here we can see that. What is NB by NA? NB by NA. Refractive index of medium B by refractive index of medium A is equal to sin 60 degree by sin 45 degree. What is the value of sin 60 degree? Sin 60 degree is root 3 by 2. And what is sin 45? Sin 45 is 1 by root 2. If we'll simplify this, it will be root 3 by root 2. Root 3 by root 2. Let's see the options. Is there any options like this? Root 3 by root 2. Yes, we have option number A for root 3 by root 2. So option A is the correct answer for the question number 14. Now we are going to see the question number 15. Okay, we are going to see the question number 15. Listen very carefully. Question number 15. A device has power -2 diopter. The device is, okay. For question number 15, what is the power given, my dear? Power given as -2 diopter. And clearly here we can see that the power is negative. Power negative means the lens must be a concave lens. The lens must be a concave lens. So all the convex lens options we should remove. So option A is for convex, so it can't be the answer, and option B is also convex, so it can't be the answer. Answer must be a concave lens. So answer will be either option C or option D. Okay, now we are going to see the focal length. We have to calculate the focal length. Power equal to 1 by focal length. Okay, diopter means what, my dear? Diopter means meter inverse. So what is focal length from here? Focal length from here is 1 by P. And what is the power given? Power is -2 meter inverse. Meter inverse will go up, then it will become meter. So 1 meter by -2. So simplify this. So it is equal to -0.5 meter. -1.5 meter. So from the options, 0.5 meter means what? It is 50 centimeter. -50 centimeter. So the focal length will be option C is correct. a concave lens of focal length 50 centimeter. Okay. Now go with the question number 16. Now we are going to see the question number 16. A light rays enters from medium A to medium B as shown in the figure. The refractive index of medium B relative to medium A will be, as we know that, suppose we have two mediums, as I have discussed in the class also, if this is theta 1 and this is theta 2, and from the diagram we can see that theta 1 is greater than theta 2, then 1 will be rarer medium and 2 will be our denser medium. A medium in which angle is more is a rarer medium, that we all know. And for a rarer medium, suppose the refractive index is n1, and for denser medium refractive index is n2, then a medium is having denser will have more refractive index, so n2 will be greater than n1. Yes or no? For denser medium refractive index is more compared to that of for a rarer medium. And from the question what they are asking, my dear, from the question what they are asking, they are asking that refractive index of medium B. Now from the options, from the question we can see that between A and B, which is rarer, which is denser. As I discussed few minutes earlier that for medium A we can see that the angle is more. More angles means that our medium A will be the rarer medium. Medium A will be rarer and medium B will be denser. B will be denser. And for rarer medium, we know that we have less refractive index. So suppose refractive index is Na, and for medium B refractive index is Nb. So B is denser, so Nb will be greater than Na. Nb is greater than Na because B is denser. So the refractive index of medium B relative to A will be, which option will be correct? A, greater than unity. Relative means what, my dear? What we have to find in this question? We have to find Nb by Na, refractive index of B with respect to A. And here we can see that Nb is greater than Na. So this ratio will be greater than 1. This ratio will be greater than 1. So option A is correct. Now read the question number 17 here. From the question number 17 we can see that question number 17 is what? Question number 17 is which of the following can make a parallel beam of light when light which of the following can make a parallel beam of light when light from a point source is incident on it? Okay, so my dear, question number 17. For this we should remember the diagram, and we remember that whenever we have a convex lens, okay, and if an object is placed at the focus, at the focus of this convex lens, then the rays after passing through the convex lens becomes parallel to the principal axis. Okay, so this is about convex lens. And for concave mirror, we also know that when object is placed at the focus of a concave mirror, then after it what happens? The ray become parallel to the principal axis. So whenever object is placed at the focus of a concave mirror or at the focus of a convex lens, then the ray become parallel to the principal axis after the optical phenomena. So which option will be correct, my dear? So the correct option will be concave mirror as well as for convex lens. So for question number 17, option A is correct. Option A is correct. Now read the question number 18. In which of the following will the image of an object placed at infinity be highly diminished and point size? So my dear, we know that whenever an object is placed at infinity, for question number 18 I am discussing question number 18. If we have a concave concave mirror, and when an object is at infinity, what kind of rays come? The rays come parallel to principal axis. The rays come parallel to principal axis from the object, and after reflection they converge at the focus. And at the focus, what we get? At the focus we get highly diminished real image. Now highly diminished and point size image. And if there will be a convex mirror, then in this case what will happen? In this case also, if object is at infinity, then what will happen? The ray will come parallel to principal axis, and after reflection they will go like this. After reflection, yes or no? After reflection they will diverge. And where is the image? Our image is here, that is at the focus. Here our image is at the focus also. Here is our image here. It is our image here. So image is at the focus, and what kind of image is here is highly diminished point size image. Now in case of concave mirror or convex mirror, when object is at infinity, we get image at focus of point size and highly diminished. And similarly, if we have convex lens, and where is the object? Object is at infinity. So from the infinity, what kind of rays will come? Parallel rays. And we know that if rays come parallel to principal axis of a convex lens, they converge at the focus. So again here at the focus, what we will get? At the focus we will get the image, and the image will be of point size. The image will be point size, highly diminished, and it will be real. Okay, because the refracted ray are meeting actually. Now if we'll talk about concave lens, then let's see about concave lens, my dear. Suppose here is our object. Okay, from object is at infinity, then parallel rays will come, and when the ray will strike the concave lens, what will happen? They will diverge. The rays will diverge. And if we will extend the refracted ray backward, then we will get an image at the focus, and this image will be highly diminished, and this image will be virtual. So now all the four optical devices, that is concave mirror, convex mirror, convex lens, and concave lens, all these four can make diminished image of point size image when object is at infinity. When the object is at infinity, so all four are capable of what? To make a point size image when object is at infinity. So which option will be correct here? So option D will be correct, that is highly diminished and point size image can be made by concave mirror, convex mirror, concave lens, and convex lens. Now go with the question number 19. Which of the following ray diagram is correct for the ray of light incident on a lens as shown in the figure? So my dear, here we can see that a ray is passing through the focus. So for question number 19, first we are going through the concept. We know that let us suppose it is a convex lens. Whenever a ray of light passes through the focus for a convex lens, then it become parallel to principal axis. This is a concept that we all knows. Now let's see the options for the question number 19. So for option A, here we can say that after passing through the focus, the ray is again passing through focus. This is not possible. Now option B, after the ray passing through the focus, it become parallel to principal axis. This is correct. This is correct. I also discussed it. I have already also discussed it. So option B is correct. Okay. So now we are going to see the question number 20. Now we are going to see the question number 20. Which of the following statement is true? Okay. Here are four options: A, B, C, and D. First thing we know that power of a convex lens is positive, and power of a concave lens is negative. This thing we know. For concave lens, power is negative. So first we are going to see the options. Option number B, here we can see that a convex lens has -4 diopter. So option B we can remove, because for a convex lens power can't be negative. So option B we can remove. B can't be the answer. And similarly option C, here we can see that for concave lens has diopter positive is given. For concave lens power cannot be negative. So option C is also wrong. So our answer will be either A or D. Okay, let's see. So let's see. And yes, one more thing that focal length of convex lens. Okay, I'm writing here only power, and no need to write here. I'm writing here power or focal length. Power or focal length for convex lens are positive, and power and focal length for concave lens is negative. So from the option here we can also see that for D part, concave lens power is given in negative, but focal length is given is positive. Okay. So option D is also wrong. Option D is also wrong, because that for concave lens power is negative as well as focal length is also negative. So we can find the correct answer from the option also, but we are going to do it mathematically. What is the power given, my dear? Power given is 4 diopter. Power given is 4 diopter. And we know that power equal to 1 by F. Or what is F? F equal to 1 by P. Now what is the power given? Power is 4 diopter. Diopter means meter inverse. So it is 1 meter by 4. 1 meter by 4. 1 by 4 is what? It is 0.25 meter. So mathematically we have also proved that option A is correct. That is, our answer will be a convex lens has 4 diopter power having focal length of 0.25 meter. Now we are going to see the question number 21. Question number 21. First we are going to read the question. You are given water, mustard oil, glycerin and kerosene. In which of these media a ray of light incident obliquely at some angle would bend the most? So to discuss the question number 21, first I am going to explain few points. Let us suppose we have some medium here. It is medium 1, it is medium 2. Okay, medium 1 is rarer medium 2 is denser medium. So when ray of light goes from a rarer medium to a denser medium, it bends towards the normal. Okay, now I'm going to draw one more diagram here. And here is the same medium 1, and I am not changing the angle of I. Whatever is the angle of incidence here, same angle of incidence here is also. Okay, now in this case the diagram is given like this. In this case, this is the diagram. So suppose this is medium number 3, and in the medium number 3 we have seen that the ray has deviated more. It is having more d, it is having less d. Here the deviation is less, here deviation is more. And we know that a medium in which the ray deviates more will have more refractive index. So if we'll talk about medium 2 and medium 3, then refractive index of medium 3 will be greater than the refractive index of medium 2. So a medium in which refractive index is more, the bending of light in that medium will be more. So now we are going to see the question. You are given water, mustard oil, glycerin and kerosene. In which of these medium a ray of light incident obliquely at the same angle would bend the most? So among the four, the one which have the maximum refractive index will be the correct option. Yes or no? For water, refractive index value is 4/3, which is equal to 1.33. For mustard oil, the refractive index value is 1.46. For glycerin, the value of refractive index is 1.47. And for kerosene, the value of refractive index is 1.44. So among the four, we can see that for glycerin, the value of refractive index is maximum. So our option will be glycerin. That is option number D. Now we are going to see the question number 22. Two convex lens of focal length 25 cm and 25 cm are placed in contact with each other. Then the power of combination is. So my dear, power of combination, I have already discussed it in the class also. Question number 22. What is the power of combination? Power of combination is power of lens 1 plus power of lens 2. And what is the power? Power equal to 1 by f1 plus 1 by f2. What is the focal length of lens 1? Focal length of lens 1 is 20 centimeter, that is 0.2 meter. So it is 1 by 20 centimeter means what? 20 centimeter means 0.2 meter plus focal length of lens 2. What is the focal length of lens 2? 25 centimeter means 0.25 meter. Now we are going to simplify this. After simplification, we will get the answer. So this is equal to 10 by 2 and this is equal to 100 by 25. So 5 and this is 4. 5 plus 4 equal to 9 diopter. 9 diopter will be the correct answer. Let's see. So the option C is correct. Plus 9 diopter. So option C is the correct answer. Now go with the question number 23. This is the last question for this part. Two lenses of power plus 2.5 diopter and minus 3.75 diopter are combined to form a compound lens. Its focal length in centimeter will be. Okay. So my dear, we are going to do the same thing here for question number 23. I am writing here for 23. 23. What is the power of lens 1? Power of lens 1 is P1 equal to plus 2.5 power of lens 1 P1 equal to plus 2.5 diopter, and power of lens 2, that is P2, is equal to minus 3.75 diopter. Okay, this is P1 and P2. We want the combined focal length. So first we will find the P net. P net equal to what, my dear? P net equal to, we know that P net equal to P1 plus P2. So we will add the both. So 2.5, what is P1? 2. What is P2? Minus 3.75. So if we will simplify this, so what we will get? 3.75, 2.5, 5, 2, 5, 2, and here 1. So 1.25. So it is minus 1.25 diopter. It is the power of combination or net power. Now what is F net? Net focal length is what? Net focal length will be 1 by F net, 1 by P net, and P net is 1 by minus 1.25 diopter. Diopter means meter inverse. Diopter means meter inverse. Now meter inverse will go up, so it will become 1 meter by minus 1.25 minus 1.25. Answer is, we have to find in centimeter. So 1 meter equal to 100 centimeter by minus 1.25. If we will simplify this, it will come out minus 80 centimeter. Okay, so or let's see the option. So for question number 23, for option D, we have minus 80 centimeters. So option D is correct. I hope that you have learned so many beautiful things by these 23 objective questions. Okay, if you subscribe, like, and comment if you have any. Okay, thank you.